In the vast expanse of our solar system, where the cold reaches of space hold untold mysteries, two icy moons, Europa and Enceladus, have emerged as beacons of hope in our quest to find life beyond Earth. These celestial bodies are not mere rocks adrift in the cosmos. They are worlds steeped in intrigue and possibility, cloaked in layers of ice that hide oceans teeming with the potential for life. As we embark on this journey of discovery, we confront a profound question that has echoed through the ages. Are we alone in the universe? This quest challenges our understanding of biology, astrobiology, and our place within the cosmos itself. Let us begin our exploration on Europa, one of Jupiter's largest moons and one of the smoothest surfaces in the solar system. Its icy exterior is punctuated by cracks and streaks, resembling a vast, frozen landscape that conceals mysteries beneath. Scientists believe that beneath this thick ice shell lies a vast, global ocean of liquid water, potentially the largest reservoir of water in our solar system. This ocean is kept liquid by the heat generated from the immense tidal forces exerted by Jupiter's gravitational pull. The resulting heat may create an environment suitable for life, similar to Earth's deep-sea hydrothermal vents. Recent data from NASA's Galileo spacecraft, which studied the Jupiter system from 1995 to 2003, provided tantalizing evidence for this subsurface ocean. The mission revealed a landscape marked by features known as chaos terrain, where large blocks of ice have been pushed upward, suggesting movement beneath the surface. Additionally, observations of the moon's surface revealed that it is constantly reshaped by internal processes, indicating a dynamic system at play. The detection of water vapor plumes erupting from Europa's surface is particularly exciting. These plumes, which can reach heights of over 100 kilometers, may carry vital clues about the moon's ocean and its potential to support life. Imagine a world where life exists in a dark ocean, isolated from the light of the sun, yet thriving in its own unique ecosystem. The possibility of microbial life, perhaps akin to the extremophiles found in Earth's harshest environments, raises questions about the adaptability of life. Could microorganisms in Europa's ocean metabolize chemical compounds released from the rocky seafloor? Could they survive in complete darkness, utilizing chemosynthesis, much like organisms that thrive around hydrothermal vents on Earth? The exploration of Europa compels us to rethink our understanding of what constitutes a habitable environment. Now, let us turn our attention to Enceladus, one of Saturn's most captivating moons. While smaller than Europa, Enceladus boasts a charm of its own, most notably the geysers that erupt from its southern polar region. These plumes, which shoot water vapor and ice particles into space, were first discovered by NASA's Cassini spacecraft, which orbited Saturn from 2004 to 2017. The analysis of these plumes revealed a surprising treasure trove of organic compounds, including simple hydrocarbons, suggesting that the building blocks of life may be present in this distant world. Moreover, Cassini's findings indicated that the ocean beneath Enceladus's icy surface may also be in contact with the moon's rocky mantle, allowing for vital chemical exchanges. This connection creates a potential environment for hydrothermal activity, akin to the life-sustaining ecosystems found in the depths of Earth's oceans. The presence of heat, water, and organic molecules paints a compelling picture of a world that could harbor life, possibly thriving in environments completely different from our own. While Europa and Enceladus share many features, most notably their subsurface oceans and potential for life, they also present distinct environments that could lead to varying outcomes for habitability. Europa's ocean, potentially in direct contact with its rocky mantle, could facilitate essential chemical reactions necessary for life to thrive. In contrast, Enceladus's more dynamic environment, characterized by its geysers and active ice, offers a unique opportunity to study its ocean without landing on its surface. Each moon challenges our understanding of habitability and expands the possibilities for what forms life might take in extreme environments. As we consider the possibilities of life on these moons, we must also contemplate the nature of that life. If microbial life exists in the icy oceans of Europa or Enceladus, how might it adapt to such extreme conditions? What forms could it take, and what biochemical processes might it employ to thrive? The study of extremophiles on Earth, organisms that survive in extreme heat, acidity, or radiation, provides us with valuable insights. These organisms demonstrate that life can be incredibly resilient and adaptable, opening our minds to the myriad ways life could exist beyond our planet. The quest to uncover the secrets of these moons is set to advance with a series of exciting upcoming missions. NASA's Europa Clipper mission, slated for launch in the 2020s, aims to conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. This ambitious mission will employ a suite of scientific instruments designed to analyze the moon's surface composition, ice thickness, and potential habitability. Its flybys will allow scientists to study the composition of the plumes and search for the essential building blocks of life. Simultaneously, the European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, scheduled to launch in the mid-2020s, will explore both Europa and Ganymede, expanding our understanding of these intriguing icy worlds. As we push the boundaries of exploration, the prospect of discovering life beyond Earth captivates our imaginations and invites us to reflect on our place in the universe. The icy shells of Europa and Enceladus may harbor thriving ecosystems hidden within their depths, much like the extremophiles that flourish in Earth's most inhospitable environments. The search for extraterrestrial life is not merely a scientific endeavor. It challenges our understanding of biology, evolution, and the very conditions necessary for life to emerge. If life is found in these distant oceans, it would revolutionize our understanding of the universe, suggesting that life can arise in a myriad of environments, each with its own unique characteristics. The journey to uncover the mysteries of Europa and Enceladus is just beginning, propelling humanity into the next chapter of space exploration. As we seek to answer profound questions about life beyond our planet, we embrace the spirit of discovery and the unyielding desire to explore the unknown. The universe is vast, full of wonders, and in the icy oceans of these moons, we may just find the keys to unlocking one of humanity's greatest mysteries. Are we truly alone? Each step we take into the depths of space not only brings us closer to understanding these distant worlds, but also deepens our appreciation for the resilience and diversity of life itself. The possibilities are as limitless as the universe itself, and each new discovery offers a glimpse into the intricate tapestry of existence that may lie beyond our earthly home.